Hey guys, welcome to our page. Here we had started the chapter number 7 lenses. Some videos already we had posted regarding this chapter. So in the first video we had considered how lenses are going to be formed, what are the different types of lenses. Then in the second lecture we had considered convex lenses and images formed by the convex lenses, and in this lecture we are going to consider the images which are going to be formed by the concave lenses. So in the previous lecture we had considered about the convex lenses. Now we are going to see it about the concave lens. Now before going to see this concept, I request you, if you are new to our page, please like, subscribe and share our page, and also press the bell icon so you will get updates in the future. Now we will consider some basic fact regarding images formed by the convex lens. Now actually convex lens is a converging type of lens, and due to which whatever be the image formed by the convex lens is actually real and inverted in nature. That means most of the time it is real and inverted in nature. So that already we had considered in the previous lecture. So for different positions of object, most of the time image is going to be real and inverted. So we have to consider same thing regarding the concave lenses also. So we have to consider some rules also, like we had considered for the convex lenses. So we can obtain the images by concave lens using the following rules. So what are the rules? So first of all we are going to see the rules. So when the incident ray is parallel to the principal axis, when incident ray is parallel to the principal axis, the refracted ray when extended backwards passes through the focus. That means when the incident ray is parallel to the principal axis, then the refracted ray when extended backwards passes through the focus, because here in case of concave lens it is a diverging lens. So that's why rays are moving away, that means they are diverging. So that's why we have to extend it backward and then it is passing through the focus. Then when the incident ray passes through the focus, the refracted ray is parallel to the principal axis. So it is quite similar to that of convex lens. So refracted ray is parallel to the principal axis. This is the second rule. So here you can see that both the rules are shown in the diagram. Suppose first case is that when incident ray is parallel, so you can see this ray PA, and after incident on a concave lens, this ray is moving along the path AD, that means it is moving away, and when we are extending it to the backward side, see, you can see this dotted line, it is passing through the focus point F1. This is the first rule. And second rule is that when incident ray are passing through the focus, then they are parallel to the principal axis. That means after refraction they are going to be parallel to the axis, and similar to that of convex lens, the rays which are going to pass through the optical center, they will go undeviated. So these types of rays will go undeviated. So therefore these are some rules which we are going to follow while considering the images formed by the concave lenses. Now we have to consider different positions of object, and according to that how images are going to obtained. What will be the position of image, what will be the size of the image, then what will be the nature of the image. So all the facts we have to consider. But here only two cases we are going to consider. The first case is that when object is kept at infinity. That means it should be distant object. It is present at very large distance. I told you in the previous lecture that condition, the object, it is said to be distant object when its distance is going to be 10 times focal length, more than 10 times focal length. So at infinity means it should be distant object, more than 10 times f distance should be there. Then position of the image is obtained on the first focus f1, that means which is present to the left side. We had seen that lenses having two focuses. So here the image is obtained on the first focus f1 when object is kept at infinity. Then size, if we consider the size, then size is in the form of point image, that means very small, you can say that. We get point image. And if we consider nature, then nature is virtual and erect. The nature of image is referred as a virtual and erect. That means we are not getting the real image, we are getting the virtual image. That means imaginary image we are getting. So that's why it is referred as a virtual and erect image. Erect means upside down or perpendicular to the principal axis. Then second position is anywhere. Now there are only two possibilities. First one is infinity and second one is anywhere between optical center O, anywhere between optical center O and infinity. That means we have to consider it anywhere between optical center O and infinity. So its position will be between optical center and focus f1. That means its position should be anywhere between optical center and focus f1. So it varies according to distance between O and infinity. Then if we consider size of the image, then small, it is very small. And again if we consider the nature of the image, then nature of the image is again going to be virtual and erect. So here we can make a general conclusion that for concave lenses, image formed is always virtual and erect, and in case of convex lens we can say that the nature of image is depends on position of object where it is kept. So most of the time it is real and inverted, but in the last case it is changing. So in this way we are able to consider the images obtained by the concave lens for the different positions. And here we can see the ray diagram now for that. So here two focuses are there, f1 which is first focus, f2 which is second focus, then O is our optical center. If objects are placed at infinity, then rays are coming parallel to the principal axis. So we had just saw the rule, when incident rays are parallel to the principal axis, then refracted rays should be extended backward and then it will meet or it will pass through the focus f1 or first focus f1. So that's why the image is obtained at focus f1 and the image nature is point image. This is the first ray diagram. Then second is anywhere between optical center O and infinity. So anywhere between optical center and infinity. So here optical center O is there and infinity means we are not able to show that infinity distance here, but we had kept the object AB beyond O and within infinity, so it is anywhere between that two points. So image is obtained between f1 and O, that means focus f1 and center O, optical center O. We got image between those 2 points, and again it is virtual and erect, that means upside down or vertical exactly. So again you can see the laws are verified or rules are verified. Incident ray is parallel, then refracted ray is diverging, and if it is extended backside it will pass through the f1, and the rays which are passing through the optical center, they are going undeviated. So in this way, by using the rules, we are able to draw the ray diagram for the images formed by the concave lens for the different positions of object. So there are only 2 positions, and in each case the nature of image is going to be virtual and erect. So this is it for today. So in this lecture we had considered about the images formed by the concave lenses, and if you haven't watched the video of images formed by the convex lenses or what are the meaning of convex lenses like that, so the links are given in the description. You can see those videos from the link. So here, thanks for watching the video. I hope you already liked, subscribed and shared our page. If you haven't done that, I'm going to request you, please like, subscribe and share our page, and also press the bell icon so you will get the updates in the future. So again, thanks for watching the video. Have a nice day.